If your lookup formula returns a blank or an error, even though the value is clearly there, the problem is often not the formula, it's the data type. One side is stored as a number, the other side is stored as text that looks like a number, and the lookup treats those as different values. That's why 123 can fail to match 123. This video is a practical checklist to diagnose that mismatch fast and fix it cleanly. We'll cover the quickest ways to confirm what's happening, then the safest ways to convert values without breaking leading zeros or IDs. We'll also talk about hidden characters, spaces, and formatting traps that make the issue look random. By the end, you'll have a repeatable approach you can use in any spreadsheet or data table. No guessing, no rebuilding your whole model. Just make the lookup keys truly comparable, and the lookup starts working again. Next step. Let's get clear on what number versus text actually means. A real number is stored as numeric data, so it can be added, rounded, and compared numerically. Text is stored as characters, even if it looks like digits. When you type an apostrophe before a value, import from a system, or copy from a web page, you often get text. Lookups compare the underlying value, not what your eyes see. So a numeric 100 is not equal to a text 100. The same problem happens with dates, because dates are usually stored as serial numbers, while imported dates might be text. Another common case is IDs that contain leading zeros. 00123 is a valid text ID, but as a number it becomes 123, and you lose the zeros. So the goal is not make it look right. The goal is make both sides the same type, on purpose. Next step. Before you convert anything, confirm the mismatch. First, test the key with a simple equality check between the two values you expect to match. If it returns false, you have a comparison problem, not a lookup problem. Next, check whether the value behaves like a number. Can you add 0 to it and get the same value? Or does it stay unchanged as text? Another quick test is to measure length. Text values have a character length, and unexpected extra characters often show up there. Also, pay attention to sorting behavior. Text numbers sort like words, so 100 comes before 20. Numbers sort numerically. Finally, watch for inconsistent alignment, but don't rely on it, because formatting can override alignment. The key idea is to prove what the data is, not what it looks like. Once you confirm the type mismatch, the fix becomes straightforward. Next step. Now let's fix the most common case. Lookup fails because the lookup value is text, but the table key is numeric. The cleanest approach is to convert the text to a number in a helper column, then use that helper as the lookup key. In many tools, multiplying by 1 or adding 0 forces numeric conversion, as long as the text is purely numeric. Another option is a dedicated conversion function that parses text into a number. The reason I like helper columns is auditability. You can spot where conversion fails, and you can keep the original value for reference. One warning, if the text includes leading zeros that matter, converting to a number will remove them. In that case, you should not convert to number. You should convert the numeric side to text instead, which we'll cover next. So the first decision is simple. Is this value an ID or a quantity? Next step. The second common case is the opposite. Your lookup value is numeric, but the table key is text, often because it's an ID. Here, you usually want to convert the number to text, not the other way around. The tricky part is preserving the exact representation. If the text key uses leading zeros, you must format the number into a fixed-width text string. That means you need a padding approach, like converting to text and then left padding with zeros to a target length. If you don't know the target length, you can derive it from the key column's maximum length. Also, be careful with scientific notation on large IDs. Some systems display big numbers in a shortened form, and converting that to text can produce the wrong string. In practice, IDs should be stored as text end-to-end, so if you control the pipeline, standardize IDs as text at import time. Next step. Sometimes it's not really number versus text, it's hidden characters. A value can look identical but contain a trailing space, a non-breaking space, or an invisible line break. Those characters make the text different, so the lookup fails. This is extremely common when data comes from PDFs, web pages, or copy-paste from emails. The fix is to normalize the text before you use it as a key. Trimming removes leading and trailing spaces, but it may not remove non-breaking spaces. Cleaning functions can remove non-printing characters, but they don't catch everything either. A reliable approach is to replace special spaces with normal spaces, then trim again. Also consider removing internal extra spaces if your IDs or codes should not contain them. The mindset here is normalize, then compare. Once you do that consistently on both sides, lookups become predictable again. Next step. Next, let's talk about mixed type columns, because they create the most confusing lookup failures. In a mixed column, some keys are true numbers and others are text numbers. That means some lookups work and others fail, even with the same formula. This often happens after appending data from multiple sources. The fix is to standardize the entire key column to one type. Pick a rule based on meaning. If it's an ID, make everything text. If it's a measurable quantity, make everything numeric. Then apply conversion and normalization across the whole column, not just the failing rows. After that, validate uniqueness. If conversion collapses values, like 0, 0, 1, and 1 becoming the same, you may introduce duplicates. That's not a formula issue. It's a data definition issue. So standardization must be paired with a quick uniqueness check before you trust the results. Next step. A special case worth calling out is dates and times. They often look like text, but in many systems they're stored as serial numbers. If one side is a true date value and the other side is a text date like 2026-04-12, a lookup can fail. The safest fix is to convert both sides into a shared, explicit representation. For example, convert both to a real date type, or convert both to an ISO-style text key that includes year, month, and day. Times add another layer because of rounding. Two times can display the same but differ by tiny fractions, so equality fails. In that case, you may need to round to minutes or seconds before building the key. The big takeaway is that dates are not just strings. Decide whether you want date math or exact text matching. Next step. Now let's make this practical with a repeatable workflow you can use every time. Step 1. Identify the key fields on both sides of the lookup. Step 2. Test a known failing pair with an equality check. Step 3. Inspect type and cleanliness, number conversion tests, length checks, and trimming. Step 4. Choose a standard key format. Numeric for quantities, text for IDs. Step 5. Create helper columns that generate a normalized key on both sides using the same rules. Step 6. Point your lookup to those normalized keys, not the raw inputs. This approach is robust because it isolates the messy part, real-world data, from the logic part, your lookup. It also makes the file maintainable. If the source data changes, you update the normalization rule in one place. And if someone else inherits your workbook, they can understand what you did without reverse engineering a complex formula. Next step. There are also a few edge cases that can make you think it's a tight mismatch when it's not. One is duplicate keys. If your lookup method expects a unique match, duplicates can return the wrong record or an error. Another is approximate match settings, where the lookup is allowed to choose the nearest value. That can hide type issues because it returns something, just not the right thing. Another is locale formatting, like commas and periods in numbers. A value like 1234 might be text in one system and a number in another, depending on separators. Finally, watch out for error values embedded in the key column, like blanks, nulls, or special placeholders. A good habit is to validate your key columns. No blanks, consistent type, and expected length. Once the keys are clean, the lookup becomes the easy part again. Next step. Let's wrap this up into a simple rule you can remember. Lookups don't fail because they're picky. They fail because your keys are not truly the same value. So treat lookup keys like a contract. Define what the key is, define its type, and normalize inputs to match that definition. If it's an ID, store it as text from the start. Preserve leading zeros and remove hidden characters. If it's a quantity, store it as a number and convert text numbers safely. When you're troubleshooting, don't rewrite the lookup first. Prove the key types, then standardize them. That one habit saves hours. If you want, share your preference in the comments. Do you standardize keys as text or as numbers, A or B? And if this walkthrough helped you build a cleaner, more reliable lookup, hit subscribe for more practical data fixes like this. Next step. Before you go, here's a quick mental checklist you can run in under a minute. First, ask, is this value an ID or a number you calculate with? Second, check one failing example with an equality test. Third, test for text by coercing with +0 or ×1. Fourth, check length to spot hidden characters. Fifth, trim and clean, and if needed, replace non-breaking spaces. Sixth, standardize the full column, not just one cell. And seventh, if you used padding, confirm the width is correct and consistent. This checklist is intentionally boring, because boring means reliable. It keeps you out of the loop of random fixes like retyping values or changing formats. And it scales. Whether you have 20 rows or 200,000, the same logic applies. Clean keys, consistent types, predictable matches. I'm always testing new ways to work smarter. Subscribe to see what workflow I'm breaking down next.